Hello, this is Jeff Hamrick at the University of San Francisco in the Financial Analysis program, and I'm going to talk about using Microsoft Excel's data analysis functionality to build a histogram in Excel. So before we do that, a quick interlude. If we're going to build a histogram, we need to build a histogram of some set of data. We could simulate some data, or we could download some data. I'm going to just randomly generate some data that we'll build a histogram of. And so a couple of reminders really quick. If you want to create random numbers between 0 and 1 in Microsoft Excel, you use this function rand, and it has no argument. So as you can see, that's a number between 0 and 1. If I want to create a large number of these things, like let's say 1,000, what you do is you take your cursor and you change it from a white cross to a black cross by dragging this over this black dot in the lower right hand corner of this cell right here. So it becomes a black cross. I left click and I'm going to drag this down for 1,000 rows to generate 1,000 random numbers between 0 and 1. Now, randomly distributed numbers between 0 and 1 will not make for a particularly interesting histogram. So let's talk about a slightly more interesting probability distribution that we could make a histogram in connection with. That is, what if we try to simulate some random numbers that have a standard normal distribution? So here's the way that you do that. In Microsoft Excel, there is a function called norm.inverse, INV, that is the inverse function of a cumulative distribution function of a normal random variable. And you don't need to understand too much of what I mean by that, other than the following fact. If you take randomly generated numbers between 0 and 1, like what we created here in column A, and you pass those through an inverse of a cumulative distribution function, you recover randomly distributed numbers that have the probability distribution of the target random variable. That is, in this case, not a randomly distributed number between 0 and 1, but a random number with a standard normal distribution. Okay? So I'm going to make my first argument here a random number between 0 and 1, and I would like that to be for a normal distribution with mean 0 and standard deviation of 1, a standard normal distribution. And so I'm going to go on ahead and create 1,000 of these as well. Let's see if I don't overshoot it. No, there we go, 1,000. And now I don't really need columns A and B anymore. Those were for illustrative purposes, so I'm going to delete these. And now let's build our histogram for this particular collection of numbers. So what I'm going to do is I'm going to highlight these numbers, or we can do that in just a minute. If you go to Data and you go to Data Analysis, we want this histogram option right here. Okay, I'll press OK, and then I need to select a particular range. A1 through A100 is not okay, but A100 through A1000 is okay, since we created 1,000 randomly distributed numbers with a standard normal distribution. And I'm going to leave all of these other options empty. It is interesting to talk about how playing with those options can change the type of outputs that we get, but we're not going to deal with that in this particular screencast. So I'll press OK. And I actually am not going to get a histogram by doing this. I'm going to get what's called a bin table. That is a table that has the left-hand endpoints of bins and the number of data points that falls into each of those bins, which you can think of as buckets if it makes things a little bit clearer to you. So what I'm going to do is I'm going to collect those left-hand endpoints of those bins along with the number of data points in each of those bins. I'm going to select that multiple set of rows and 2 columns, and I'm going to go to Insert and choose Column right here. Okay. When I do that, I want the very simplest option under 2D column, and I clearly get something that is the histogram I am going for, but then I get this other crap right here with the blue bars. That's because Microsoft Excel is making a bar chart involving column A and column B. We need to fix that. We'll do it in a second. Before we do that, let's kill this annoying thing right here. Click it and press delete. And then what we're going to do is get rid of these blue bars. So right click, select data, and let's do the following. Series 1 is the column, the stuff in column A. We don't want a bar chart of that. We want a bar chart of the number of data points in each of our bins. That's series 2. So I'm going to click on series 1 and remove this. But series 1 is in fact the information that I want in my horizontal axis labels. So I'm going to edit this and use the horizontal axis labels that are implied by this bin table that we created. So I'll choose those and press OK. OK again. And notice that we're getting a little bit closer to what we might want. I think that this looks fairly hideous right here. The way you can suppress the display of so many decimal points is actually to go over to these bin left-hand endpoints right here and use this option right here to eliminate some of those decimal places, and that change will be reflected right up here as well. Okay, and then the next thing we need to do is we need to remove the space, it's kind of annoying, between the bars, because a true histogram doesn't really have these awkward gaps between the bars. So I'm going to click on these bars and then right click and ask to format the data series. And what we want to change here is this gap width. We want to go from not to a large gap, but to no gap between the bars. So we want to set this to 0%. And when we press close here, what we see is that the histogram has been modified so that it looks almost like a probability density function. It's certainly a discrete approximation of a probability density function. It's not quite a probability density function since the area underneath it is not 1, but with some additional normalization that's beyond the scope of our discussion, this y-axis could be changed so that we did have a probability density function. But nonetheless, I think you're convinced by looking at this that the distribution that we have is plausibly approximately standard normal. If we didn't have 1,000 data points, but maybe 10,000 or 100,000 data points, I bet the picture would look still even more convincing. Okay, so it doesn't matter whether we're dealing with stock return data, other data in a financial context, or data that were generated in Microsoft Excel itself at random. This is how you use Microsoft Excel to build a histogram. Thanks.